Hello. In this session we will be discussing about the problems on DC drive. In one, the DC drive will be fed from a chopper, and in the other the DC drive will be fed from a single phase rectifier. So without wasting any time, let us start. But before that, if you are new to my channel and want to stay updated with my latest videos, please make sure to subscribe to this YouTube channel by clicking the red button in the right hand below corner. Subscribe to Tech Talks and hit the bell icon to get notifications about coolest and latest engineering technology in the first place. So the first step of solving this problem is to draw the figure. So let us draw the figure. We will consider one buck chopper. We are considering a general switch with a diode, and the DC motor can be represented by a resistive inductive load having a back EMF. Okay, so this voltage, this is input voltage, this voltage is given as 400 volt. Okay, the resistance that is given as 0.1 ohm. Inductance is not given in the question, so we will consider it to be 0. And this is EB, back EMF. Let us name it as VS, V supply, and voltage across this part we will call it as VDC or DC voltage. Now, what is asked in question is that what is the input power? Input power is what? Speed is what? Torque is what? When duty cycle is 60%. And it is also given that the current flowing, average current flowing in this path is 150 ampere. And the voltage constant kV of the motor is 4 volt seconds per radian. Now we will solve this one by one. So the first thing that should be noted in this example or in this numerical is that the motor is connected with a buck chopper. So if this is Vs, then VDC would be VDC. This would be duty cycle D into Vs. So this makes equal to 0.6 into 400. That is 240 volts. Now this 240 volt is divided into VDC. This is divided into IARA plus EB. IARA plus EB. Now this is equals to 240 equal to IA is 150, RA is 0.1 plus EB. EB can be written as kV into omega R. So from here we can get that omega r equals to 225 by 4 radian per second. So we have already got the speed. Now the torque. The torque is equals to kV into Ia, that is 4 into 150, that is equals to 600. Now the next thing is that 600 Newton meter. Now the next thing is that we have to find the input power input. So voltage here is VDC into IA, so that is equals to VDC is how much? 240, and IA is what? 150. So this is equals to what? 240 into 150, that is equals to 36000, that is 36 kilowatt. So we have got these three results. Now we will move to our next step. If you need the basics of this part, do let me know in the comment section, and do subscribe to Tech Talks and keep updated. Now moving on to the next part. In the next part, it is asked that what will happen to the speed if the duty cycle is varied from 10% to 80%. Okay, so the duty cycle is varied from 10%, that is D1, it is 10%, 0.1, and D2, it is 0.8. Now what will happen to the speed? So we will use the same equation. If D1 is 0.1, then VDC1 will be equal to 10% of 400 volt, that is 40 volts. Now this VDC, this will be divided into IARA plus EB. It can be written as VV kV into omega R minimum, omega R1 is equals to 40. Since the load is constant, so IA will be constant. So this here it will be 150 into 0.1 plus 4 into omega R1 equals to 40. So this will give you omega R1 equals to 6.25 radian per second. Now this is VDC1. What will happen if the VDC2 is 80%? So then VDC2 will be 0.8 into 400, that will be 320 volt. Now the same thing will be happening over here. So that will be what? 150 into 0.1 plus 4 omega 2 is equal to 320. So from here we can find out that 4 omega 2 equals to 320 minus 15, that is 305, that is omega 2 is equals to 76.25 radian per second. So these two are our answer for this second part of the question. Now you can keep it in radian per second, or you can change it to RPM. That is very easy. Subscribe to Tech Talks and hit the bell icon to get notifications about coolest and latest engineering technology in the first place. So our first step will be drawing the circuit diagram and understanding the problem. In my videos you will see that I give more emphasis on drawing the circuit diagram. This is because if you draw the circuit diagram, then a better understanding of the problem happens. So this is step 1. So this is the AC source that is connected to a full rectifier, so fully controlled rectifier with a thyristor, and the other side of the thyristor is connected to a motor, and the motor can be represented as a resistive inductive load with a back EMF. So this part is the motor. So the values that are given in question is that this AC is 230 volt, 50 hertz. So if it's not given anything, so this 230 volt is RMS voltage. Now in the question it is asked that what is this alpha? Alpha will be what? The armature resistance is given as 1 ohm, inductance is not given, so we'll take it as 0, and this is EP. A rated condition is given. In rated condition it is told that this motor is 220 volt motor. 220 volt motor. This means what? This means the terminal voltage V, let us name it as VDC. The VDC is 220 volt. It is the current that is going in this direction is 10 ampere. That is the rated current IA. At this position, the speed of the motor is 1000 rpm. So this is the rated condition of this, what is given in the question. So moving on to step 2, we will see if rated condition is given, then what more we can tell about this motor. Okay, so this voltage, that is VDC, this is equals to IARA plus EB. Now when VDC is 220 volt, IA is 10, RA is 1, and then EB, this one can be written as voltage constant of the motor into omega r. So if you convert this one RPM into radian per second, it will come as 104.72 radian per second into 104.72. From here you can find out that kV is equals to 2.005 volts second per radian. Here also you can find out what is the rated torque, though it is not asked, but still you can find it out, or you can leave it whatever you want to do. So this rated torque is equal to what? kV into Ia. So this is equals to 20.05 Newton meter. Moving to our next step, that is step. It is asked that what will be alpha when rated motor torque at 500 RPM is applied. So here two things are important. One is that since the motor torque is rated, that means it is indirectly telling that Ia, this current, is constant. And the next thing is that VDC, this voltage VDC, this one can be written as 2Vm by pi cos alpha. If you want details of how it is written, you can comment me in the box. I will make a video on this. Okay. Now this VTC is 2 Vm by pi cos alpha, where Vm is the peak voltage of this AC side. This is the RMS value. But Vm is actually peak voltage of this 230 volt. Okay. So this VTC, this will be equal to IKRA plus EB. EB, it can be written as what? It can be written as kV into omega. This omega is not omega r, not this speed. This speed is equivalent to 500 rpm. Okay, so let me write it as omega 1 to avoid confusion. So if you just go on putting this value, this will come as 2 root 2 into 230 by pi cos alpha equals to 10 into 1 plus kV. kV is what? 20.05 into omega 1, that is 500 into 2 pi by 60, changing this RPM into radian per second. So here you will get that cos alpha, this is equals to 0.555, where alpha, or the firing angle, let us limit as alpha 1, where this firing angle alpha 1 is equals to 56.26 degree. So this is our answer for what is needed. Alpha, that is the firing angle, will be 56.26 degree. To the next part of the question, that is our step 4. It is asked that what will be alpha when half of rated motor torque is applied at 500 rpm. So half of the rated motor torque is applied. What does it mean? This effectively means that the current of the rated condition at rated condition is half, that is 5. So we will be applying the same formula over here, that is VDC equals to IA. Now I am writing it as IA1 RA plus KV into omega 1. So this VDC is what? 2 root 2 into 230 by pi cos alpha 2. IA is what? IA is half of the rated current, that is 5, into RA. RA is what? RA is 1. Now this KV into omega 1, this will be what? 20.05 into 500 into 2 pi by 60. So if you calculate from here, you will get cos alpha 2 equals to 0.53, from where you will get alpha 2 is equal to 57.91 degree. So this is our answer 2. If you have any doubt in this solving, do comment in the comment section, and please subscribe TikTok and keep updated with more such numericals. Comment below about how you like this video. Check out the links in the description box about more such videos. Do click the like button if you like the video. If you are new to this channel, subscribe TikToks and don't forget to hit the bell icon.